Hi guys, today we'll be looking at the rules of indices. It's an introductory lesson, so this is the first video of a few that I aim to produce. So first things first, these are 4 rules we'll be looking at. So pause the video and make a note of them now. So anything to the power of 0 is 1. We've got these instances where we add the powers, these instances where we subtract the powers, and the instance when we multiply the powers together. So we're just going to do a sequence of worked examples, and then hopefully by the end of it, you'll feel a lot more confident about how to answer these questions. So let's go to the first set. So these are past paper questions. So the first one, we have x power of 8 times x power of 3. You can see from the second rule on the top, we add the powers together. So we get x to the power of 11. B, this is an example of the fourth rule. This is an example of the fourth rule that you can now see. So we have 5y cubed. So think of it as you're cubing 5 and you're cubing y. So that'll be 125 and y cubed. So the answer will be 125y cubed. And C, we have w to the power of 7 divided by w to the power of 4. So in this instance, we will subtract the powers, and so we will get w to the power of 3. Okay, next, what do we have? 3 more. So again, if you want to give them a go, pause the video. But on this first one, we've got the second rule where we add the powers, and it's as simple as that. B is harder here. So we've got 3 things that we need to cube. So we have 4 cubed, we have b squared cubed, and we have c cubed. So that would be 64, b to the power of 6, and c cubed. So the answer will be 64, b to the power of 6, c cubed. Just like that. And c, which seems to be easier than b, we just subtract the powers like in the third rule. So it will be d to the power of 5. So hopefully you're getting more confident. So we've got some involving numbers now. So I'm going to adjust that because I'm pretty sure that's supposed to be an m. Let's just rewrite that question. There you go. So we have 2m squared times 5m to the power of 6. So in this case, we need to do these bits separately. So what we have is 2 times 5, and we have m squared times m to the power of 6. Well, we know 2 times 5 is 10. And when we're timesing indices, we're going to add the powers. So we just put these 2 bits together, and we have 10m to the power of 8. For part B, it is a similar logic. So this time we have 15 divided by 3, which is 5. And we have p to the power of 3 take away 4, which will be -1. Yeah, so in instances like that, we just treat each bit separately. Next, what do I have? We got some of rule 4. Part A, we do t cubed to the power of 4, which is t to the power of 12. And for B, The way you write it is actually quite important. So I'm going to stack it and consider each bit separately. So what we have is 12 divided by 3. We have m divided by n. What's anything divided by itself? Exactly, it's 1. And we have n6 divided by n to the power 4. So we take away the powers. That'll be n squared. So the final answer will be 4 times 1 times n squared. So 4n squared. So you can see if we just consider each bit separately, it is a little bit easier. Yeah? All right. What's next? Oh, the first rule. What's anything to the power of 0? Exactly. It's 1. 1. So that's the answer. 1. Yeah, anything to the power of 0, i.e. x, is 1. Next. 2m squared all to the power 4. So what goes to the power 4? Exactly, all of it. So we have 2 to the power 4, m squared to the power 4. 2 to the power 4 is 16, because it's 2 times 2 times 2 times 2, not 2 times 4. And then this will be 2 times 2 to the power 2 times 4, which m to the power of 8. So the final answer will be 16m to the power of 8. Yeah, we put those two bits together. Hopefully you got that. If not, make a note of it. So this one, we have 3 bits involving 2 rules. So we could do it separately and do 3 to the power 4 times 3 to the power 5 is 3 to the power 4 plus 5, which is 3 to the power 9. And then do 3 to the power 9 divided by 3 squared, and we'll eventually get 3 to the power 7. Or, alternatively, we could have 3 to the power 4 plus 5, take away 2. Either way is right. Yeah, doesn't matter which one you do, you'll get the right answer. Then what's next? Right, give this one a go. Again, pause the video. Welcome back. So we've got 2 to the power 9 plus minus 2 minus another 4. So the answer will be 2 cubed. Yeah, the question is work out the value of. So we'll put the value of 2 cubed, which is 8. Yeah, alternatively, you might have ended up going 2 to the power of 7 divided by 2 to the power 4 is 2 to the power 3. Either way, you should have got the final answer of 8. Oh, we got a fun 3 to do there. So A, p cubed times p to the power 5, we add the powers, so we get p to the power of 8. B, we cube everything, so 4 cubed, a cubed, b squared cubed, so 64, a cubed, b to the power of 6. So that will be the final answer. And for C, again, we're going to do each bit separately. We have 16 divided by 4. We have m to the power of 7 divided by m to the power of 3. And we have n cubed divided by n. Well, 64 divided by 4 is 4. 7 take 3 is 4, so that will be m to the power of 4. And an n on its own would be to the power of what? exactly 1. So we end up with n to the power of 3 take 1, which is n squared. So the final answer for C will be 4 m to the power of 4 n squared. So just be careful in these situations where you think of that as n to the power of 1. Excellent. Have I got any more? We do. I have a few more. In this one, we're going to just consider these bits separately. So we have 9 times 2 and p 3 plus minus 2. So we end up with 18 to the power of p, or p to the power of 1, but we don't need to put the 1 down. B here, we need to cube everything. Cube everything, cube everything. That's 125, x to the power of 6, y to the power of 6. So that will be the answer. Happy? Excellent. And that brings us to the end. So I hope you've enjoyed that video and it's been useful to you, for you. Obviously, watch it through, make some notes, and maybe practice the examples. So I've been Mr. Raz. Thank you.